Hello and welcome back there. Just going over a few things. Going to be using a couple little boards and whatnot here to move to the next step in this frame system. You might be able to see on here that I've created a little bit of a carriage out of PLA, replaced the foam block. See if I can get this up where it'll focus. All it was some pieces that I printed to give the block that would fill in the space, and then a right angle adapter, pretty much just sliced from the same block inside Tinkercad. And they're actually not glued, they're just held in place with some really good double-sided tape that I got from Banggood a couple years back. In fact, that tape is probably almost permanent now that it's been on there for a few days. But I will be able to mount a laser or whatnot on this. I just have a bolt in there, but you could have my old 200 milliwatt red laser will probably be on there when I get this all set up, or you could have it pass through that way and then have it be mounted this way. I'm not sure which way I'm going to do that yet, but all that's possible. On this end, I'm just going to have a quick look at, hopefully not bump everything around too much, beat the camera up. There's what I'm calling a Y bracket, if it'll focus here. It's a pulley block basically. It's all ABS, sorry, it's all PLA right now. There's no, I actually moved a bit there. I just have that tape down, so it's a bit hard to pull. There's no metal or anything in that yet. This is just for testing purposes, but it's basically a little pulley block at the end of the opposite end of what is going to be the stepper, way to get some motion on that little carriage. Now its Y block, or pulley block up in there, is a little different. The hole on the top has been widened to allow a special shaft on the stepper. Can't get that quite to sit still. Bit tough to hold this one. And an adapter piece that allows the motor to zip tie on the top. But essentially that becomes the output side, and they can be placed anywhere on the frame. I'm just going to rest that down there so I stop hitting the camera with it. But that little motor, it's just got nylon string, kite string at the moment, until I can get some nylon, like fishing cord or something like that, with some really good strength to it. This stuff is very strong, but it's actually also quite smooth, so it actually slips in testing. And in this motor here, I did the red wire mod. For those that have had these motors, you can go inside and clip a trace. You can go inside the blue cap on the motor and cut the little trace on the board that goes from both sides of where the red wire goes in, and then you can remove the red wire completely from the wires going in, and that turns it into a bipolar or a 4-wire stepper motor permanently, well, semi-permanently, because I suppose you could go in and fix it. But what that allows is it to run with an easy driver, which is a 4-wire stepper motor control board. It'll run much cooler and quicker once you've converted it to the proper bipolar mode for this. They normally run with a ULN 2003 driver, which is a Darlington array, and I may have mentioned them before and shown them before, but that just allows you to pulse to each of the 4 control wires ground, and it would be the positive is common in the motor, and then depending on which of or how many of the other 4 wires you put ground to changes how the steps go in the motor. But these are not compatible with that. You can't use a bipolar driver on a motor like that and get 100% efficiency, because the middle of the 2 coils would be connected together. So what you do is you go and just cut that. You cut that link, and then it makes it a proper bipolar, and then we'll work with your nice cheap little easy drivers. And you could use the ULN 2003, but then you have to have software to control the pulses and whatnot. Whereas if you're using these, you just have to have your direction and step pulse pins. So basically a ground, your step pulse, and your direction pin. And that means really you only need 2 digital outputs to run a stepper motor when using an easy driver. And there's some other settings on here like micro stepping mode and power in there. And you can actually pull power back off of these back to power up your Arduino. So you can supply like 12 or so or 20 volts over here. And then this will output 5 volts here for your Arduino. You can get these in little packs. I think you can get a pack. I bought a pack of 5 for like $4 not too long ago. And I just soldered up the heads as best I could. See if I can get this to focus here for you. And makes working with steppers very easy. I don't know if this will stay focused. And I just stuck it in a green tiny breadboard here. It makes quick setups of tests. Real simple with those, actually. They just fit perfectly. And then of course there's our old Arduino Nano. I think this one actually came from Hari. I'm not sure if this is one of the ones from Hari or one of the ones I had a spare one from an older project lying around, but I think this is the one that Hari sent me a little while ago. And so I'm just going to say thanks anyways. Shout out to Hari there. I'll put a link in the description or whatnot to his channel for those of you that don't know it, but I'm pretty sure most of you do. Anyhow, I'm going to either put my own custom laser controlling firmware on this, which my bigger one downstairs, my homebrew, actually runs now, or I'm going to put the GBRL, some people call it Gerbil, some people call it Gerbil. I'm just going to use the acronym GBRL. I could put that on there and try and set this up. There's something coming that I don't really have a picture of yet or the part made, and I'm going to try and make it tonight. And that is a set of end caps that are fixed to each other that allow a set of rails like this to actually move inside an outer set of rails. The problem is, right now, I only have about 1.5 feet of, I only have about 50 centimeters of extrusion left. I've kind of bent some and used some on other things, so I'll have to get some more of this. And I don't know if you can see here, I didn't have this last time. Some people wanted to know. See, will that focus? It's kind of hard to hold it and get it to focus here at the same time. So, you know, 6 foot, super cheap. And Cincinnati, Ohio. Never saw that last time, but anyhow, it's actually aluminum corner brace. And the idea with this is if you have a piece of plywood, you protect the corners with this. In fact, I probably would have done my shop desk with this. But I kind of actually like a wooden edge. And for those that haven't seen, I have my big yardstick or meter stick. I'm just going to pull this back and see if we can see that. I've got my meter stick just kind of resting at the bottom. I would have probably put some L bracket there, but not where I do various projects. I like to be able to remove it. But anyhow, get back to the topic at hand. Just wanted to update the stepper mount, and something I'm going to say just quickly. The pulley on this side is identical to the one here. I just use the wider hole at the top so that the updated motor shaft or pinion comes through, but the motor is held down on a part like this that I made. It's in Tinkercad. I modeled the motor in Tinkercad, and then I modeled all the possible ways I could hold it, and I came up with this, where I could just put some Gorilla Glue, rough this up, and put some Gorilla Glue on the back of that, and then it would glue into place down there on the 45-degree angle. Or you could, if you did it in ABS, you could solvent weld it. And then right now, if you can see, I'm just using zip ties to hold the motor down, and I mean, it's quite solid. The wiggle that you're seeing here is not that mount. I actually made a mistake when I printed this holder. I don't know if you can see the green. How well is it going to show up if you can see the green in here where my finger is? I accidentally over sanded the V groove in that, and that of course made a little bit of slop in play. So I'm going to be reprinting that part after I get a functioning test going. But as it's under tension from the wires, it doesn't make much of a difference. I could just put a plastic shim in it or something later. But anyhow, just a small update of some things that I have going on this. Maybe tonight I'll get a chance to get this wired up so it can drive the stepper motor. I'll just run it from my bench supply back there. My messy desk as it is. I'll just tilt this up and you guys can see my messy desk up here. Over in the corner is an older CD-ROM based unit. It uses the axis on a CD-ROM and some Adafruit motor shields, and that's the that's the 8266 in a Terminator CPU looking block thing, just sitting there waiting for some parts and stuff as usual. That's the one thing about having to get things from overseas, and one of the reasons why I wanted to come up with these, I wanted something simple that you could print in an hour or two at the house, go nice and slow, make them nice and solid. I've had one fellow tell me apparently you can go over the surface of them quite quickly with a micro torch, and it of course makes the surface really smooth. But if you go over it with a micro torch and a hot piece of metal, quickly you can not only get a smooth surface, you can somehow re-weld or fuse them better. But I find if I just print slowly with a high heat near the maximum of what prints well, they become very solid. Now I have had a couple split and whatnot. I've tried gluing in the different heats. That's all been working, so I'm not going to worry about that for these kind of things. It's not meant to run forever. This is meant to run for, get your idea working, and then you could maybe then invest in getting some 2020 bar or whatever you're doing. Or if it's light duty and you're not running it all the time, it might be good enough. So that was the point for all this stuff. And then of course, most of what you see here is probably less than, even if I had the two of these, I got a bag of 5 of the easy driver boards for like $4. The heat sinks come from the computer chipset. Not sure if I mentioned that before when I showed my other one. The chipset heatsink, and I just cut it into I think 9 ways, and you know, most of the stuff is pretty cheap. Anyhow, that's my update, and hopefully I'll get to some of that today. And as always, like if you like, comment if you've got any questions or ideas, and don't forget to subscribe. Thanks.